Okay, students, in this video we're going to explain how to divide rational expressions. So suppose that I give you the following division. 5x plus 25 divided by 49x to the third y divided by x squared plus 7x plus 10 divided by 14xy to the fifth. As you see, we have a quotient of two rational expressions, or division between two rational expressions. The first we're going to do is to rewrite this division as a multiplication, and to do it we have to flip the second expression, or to multiply the first rational expression by the reciprocal of the second rational expression. So basically what I'm going to do is to keep my first expression exactly as is there. I rewrite the division as a multiplication, so it's not multiplication, and now I flip the second expression. So the denominator becomes numerator, and the numerator becomes denominator. Now it's time to factor. So factoring 5x plus 25, we have a common factor 5. We factor 5 out. The expression below, the main 49x to the third y, is a monomial, so it's going to stay like that. The expression 14xy to the fifth is another monomial, so it's going to stay like that. And the expression x squared plus 7x plus 10 is a trinomial, so I'm looking for the factors of 10, so that adding those factors we get 7, and those factors are 2 and 5. So it's x plus 2, x plus 5. Because 2 times 5 is 10, and 2 plus 5 is 7. Now we're going to simplify here the common factor x plus 5. And also, I know that there is a common factor 7 between 14 and 49. So I will divide both 14 and 49 by 7. 14 divided by 7 would be 2. 49 divided by 7 would be 7. I didn't finish, to simplify yet, but now I will just rewrite as a pro, the factor that I still have there. So I have 5 times 2, so multiplying 5 times 2 here, we get 10. And then we have xy to the fifth. And what I have below I have 7 x to the third y, and the binomial factor x plus 2. Of course, I have now to simplify the x and the y's, right? Using the properties of exponents, the rule of exponents. So I'm going to say this is 10 x over x to the third is x to the 1 minus 3. Remember that these factor x with no exponent have an invisible exponent 1 as well. This y here have an invisible exponent 1. So we have now y to the power of 5 minus 1. Below I have the 7, and I have x plus 2. Then I have 10 x to the power of 1 minus 3, 1 minus 3 is negative 2, so it's x to the power of negative 2, y to the 5 minus 1 is y to the power of 4 over 7 times x plus 2. Now let us recall one property of exponents, that is the negative exponent rule, that says that if we have x to the power of negative n, this will be the same as 1 over x to the n. So if I have a negative exponent, I will bring that exponential expression, if it's in the numerator, to the denominator with the exponent positive. So that means that now I can do this. Let's say this is 10, x to the negative 2, it goes down, sorry. So below I have the 7, the x to the negative 2 goes down as x to the second, positive. The y to the fourth stay in the top, and the x plus 2 stay here in the bottom. And this will be the result of my division. 10 y to the 4 divided by 7x squared times x plus 2. So that's what I get when I divide the given expressions.